and Chad Montgomery, and today we'll be presenting our case study on wind utilization in manufacturing facilities. As the world is pushing for more renewable energy sources, one of the most obvious sources that comes to mind is harvesting wind energy. There are many different aspects that must be considered when attempting to use wind energy, including a lot of downsides. But if we can overcome these drawbacks, we can utilize this renewable energy source and lower the natural gas and coal usage. One of the most obvious drawbacks that must be taken into account is the fact that wind is not consistent, and in different areas, the wind can be considerably more or less. I have a map here that shows the United States, the average wind speeds across the United States, as well as it has wind power plants and places that manufacture things to harvest wind energy, such as turbines. With this issue, the solution would be to store the energy that we harvest, but until we improve the technology that we have to store energy, this is not a viable option. For a brief history of wind energy harvesting, this has been utilized for over 1,000 years, with the first reliable sources dating windmills back to 644 AD. These windmills had a vertical axis of rotation, as shown on the slide. These first windmills were used mostly for milling grain, but they were later also used to pump water, and they were used in sawmills to cut lumber. But once these rural farms were put on the electric grid with the invention of the steam engine, these windmills got they were basically made obsolete. And only in more recent times, with the push for renewable energy, have they come back into the mainstream approach for energy.
Okay, so here in this sketch, we have our approach in how we're going to use wind turbines to save energy in a manufacturing related environment. So here to the left, we have our plant. It's the this is the model from the homework 3 in measuring, and we have a boiler with a feed water pump, and our direct savings will come directly from the feed water pump as we're trying to power the feed water pump with the energy conserved from the wind turbine. And to the right here, we have our wind turbine, which will directly power a pump. The pump will pump water to a high pressure tank, which will have a pressure head that powers a turbine. And the power from the turbine will generate enough to power the feed water pump. And the water used from the turbine will be cycled through the system. And here to the left, we have the feed water conditions. The pressure is 12 psi-G and the mass flow rate is 164.05 kilopounds per hour. These were taken from the measure. And to the equations that we used, we have a couple easy conversions here for gallons and pressure head. But the main thing here, we have a flow rate for the system, and that will consider the turbine efficiency. And then we have a theoretical pump flow rate for the pump at the for the wind tunnel. That will be used for the pump requirement, such as the GPM of the pump.
Okay, so then after we got our design down, we want to do a financial analysis, and the first part of that was picking out some real components, getting some prices off of it. So the first component we picked was a vertical axis wind turbine, and it can generate 10 kilowatts of power at a max wind speed of 10 meters per second. And it was picked just because it was cheap and readily available from Amazon. And while this might not be exact what you'd implement in a plant, it still gives a roughly accurate pricing on what it would cost in the plant. And while we don't need 10 kilowatts, we need more around 3 to 4 kilowatts of power. That the windmill still makes power at lower speeds, because as you can see here, 10 kilowatts is about where is about in the red and blue section. So it'll kind of only be here where it'll be able to output 10 kilowatts on average, but it still generates enough power all the way down to 5 meters per second, which is, you see here that 5 meters per second is about at the top of the green. So everywhere except the green, you only need one windmill. And if you got below that, the green areas, you need 2 windmills, and that encompasses pretty much the entire US. So this would be a usable option for all of the US. And then for the pumps and turbines, I found the pump off of Water Pumps Direct, and it would supply enough power with the wind turbine to pump the water up to the upper tank, and it costs $1,369. And again, this is probably isn't exactly what you use in a plant, but it's a generic pump that you'd see in many plants and roughly right cost estimate. And then I also found the turbine and generator for $3,729 that are also just common parts. So then with those costs, as well as the cost of the tanks and piping and whatnot, we took that, and then there are also some variable costs like how much piping length there is, design costs, and labor, obviously. So we decided to just double the cost of material, because that's kind of a good rule of thumb that I've used before, and it gets you up to about $11,000, which will give us a good starting point to base our financial analysis off of. And then we calculated the electric saving based off of how much power we would save from not having to power the feed water pump for plant with grid power instead of with just powering off of the turbine. That gives us a payback period of 6.8 years and an IRR of just 0.78%, which isn't great because most companies you need about an 8 to 12% return. So almost every company would deny this from the finance department to get built. But there are some other things to consider. One of the big one is ESG scores, which every corporation actually has an ESG score, and most investment firms look heavily at this. Some even consider it more than they consider profits. And ESG stands for environment, social, and governance. And this is basically the actions and policies that a corporation takes other than just making profits, just make sure that it's a good company and they're not dumping a bunch of waste in the oceans and stuff like that. So this would obviously be a big improvement on the environment side. So, and many companies spend a lot of money on carbon credits and things to improve that score. So even though this doesn't make that much money, it still would pay for itself eventually and would improve the score. And then you also have the added benefit of not being reliant on the grid. So you have a little bit of backup power to like a generator, because that turbine can still make power even if the grid's off. So overall, most companies probably wouldn't implement this, but if you're in an area with high wind speed or even just decent wind speed and looking to improve some of the other factors, it could be plausible, and probably some more engineering, you'd probably get a better efficiency and costs on it. Here's some of our sources. Thank you very much.